Hey guys, what we're going to talk about today is the combination of functions, okay? So today we're going to focus on 4 ways to put functions together, okay? Now there's actually a 5th way called composition, okay? And you talked about that before in Algebra 2, and we're going to get really into that more on our next lesson, okay? But today we're just going to focus on these 4 ways, all right? So just as you can add, subtract, multiply, and divide numbers, you can add, subtract, multiply, and divide functions, okay? So we're just going to make sure we understand how to do that, all right? So let's start off with this first one, f of x plus g of x. Well, we know, based on given information up here, that f of x is 2x plus 3, and g of x is 4x minus 1, all right? So what we can do is we just simply say, okay, well, f of x is 2x plus 3, so 2x plus 3, and we know that g of x is 4x minus 1. All right, now I can just put like terms together, right? There's no other processes I need to do. 2x plus 4x is 6x. 3 plus negative 1 is 2. So 6x plus 2. Done. That's all there is to it. All right, let's do g of x minus f of x. Now, notice this guy has a minus sign. It's going to go to everything in f. That is the biggest error I see on these kind of problems from students, okay? They forget that this minus sign needs to go to everything in f, okay? So g of x, 4x minus 1, 4x minus 1, then minus, now I'm going to put f of x in parentheses. The only time you see me put it in parentheses is because there's a minus sign in front, and I don't want to forget to put the minus sign to both terms, or to all terms. Let me say all terms in f of x. So now I'm going to distribute that minus sign. So I say 4x minus 1, and then negative of positive 2x becomes negative 2x, and negative of positive 3 becomes negative 3. And now I just put like terms together. 4x minus 2x, that's 2x. Negative 1 minus 3, that's negative 4. Bam, there we go. That's all there is to it. All right, next one. F of x times g of x. All right, so that's just where we say 2x plus 3. Now I'm putting everything in parentheses because when you're multiplying functions, you have to remember that everything from one function has to, at some point in time, multiply to everything in the other function. So in other words, what I mean by that is I'm saying that the 2x from the f of x function needs to multiply to everything in g. And the 3 from the f of x needs to multiply everything in g. So that's why I put everything in parentheses so I don't forget, okay? So I'm going to say 2x times 4x, which is 8x squared, okay? And I'm going to say 2x times negative 1, which is negative 2x. And I'm going to say 3 times 4x, which is 12x. And then I'm going to say 3 times negative 1, which is negative 3. Whoops, that just popped up. All right, so we look here and we say, okay, what are the like terms I can put together? Well, I have 8x squared. Then I can put negative 2x and positive 12x together, and that gives me 10x. And then I just say minus 3. Okay? And that's it. That's all there's to it, because we're not solving, we're not doing anything like that right now. We're not even evaluating. We're going to evaluate here in a second. But we're not even evaluating at this point in time. We are simply multiplying. Simply multiplying, okay? F of x divided by g of x. Okay, so this time we're dividing. Okay, so we're going to take our top function, 2x plus 3. That's our f of x function. And we're going to divide it by 4x minus 1. And you'll notice that there's really nothing else you can do here, okay, as far as like simplifying, okay, because there's no greatest common factor in 2x plus 3. That's also in 4x minus 1. There's no way of factoring either one of these, so you can't cancel anything out, all right? You cannot cancel out the x's. In order to cancel something out on top and bottom, it has to be in everything on top and in everything in bottom. So you cannot cancel out these x's, okay? You cannot cancel out the 2 and the 4, because does the 3 have a 2 inside of it? No. Does the 1 have a 2 inside of it? No. So you cannot cancel unless everything has inside of it. That's kind of like multiplication, all right? Now the only other thing I encourage you to do on this problem is just to take it a step further, is to write a restriction for the domain. What that means is you just simply say, okay, what kind of values can x not be? Well, I know that I cannot have a 0 in the denominator, so I know that x cannot be whatever value would make the denominator become 0. So I just simply take, set it equals 0, add 1, divide by 4, so I get x equals 1/4. So then that's the only value of x it cannot be, so x cannot equal 1/4. So I would just like for you to attach that on at the side. You may have seen this in prior math classes where you see something attached on the side, something like this. Usually something like x cannot be 0 or x must be greater than 0 or something like that. That's called a restriction on the domain, and so now we're just setting that up for our problem as well. We're just simply saying, hey, this function works as long as x is not equal 1/4. If x equals 1/4, this function has an error. Okay? Everyone got that down? All right. Let's now consider a different idea. Let's say that I wanted to say something like, oh, let's say I want to do f. I want you to say evaluate the function at 2 minus the g function evaluated at 2. All right, so let's say I want you to do this guy right here. All right, there are two different ways we could approach this problem. Okay, so first off, make very clear, what is this problem saying? It's saying the function f evaluated at 2 minus the function g evaluated at 2. That's what it's saying, okay? So the first way you can approach this problem is just by simply saying 2 times 2 plus 3 minus, okay, now we're going to put the g function in parentheses, 4 times 2 minus 1. All right? And now you just basically put everything together. You know, 2 times 2, that's 4. 4 plus 3, that's 7. Minus 4 times 2, that's 8. 8 minus 1 is, well, that's crazy. This is going to be a 0. 7 minus 7, which is 0. All right? So we got 0. All right? Another way we could have done this problem is rather than plugging in 2 first, so the problem is still f of 2 minus g of 2, but rather than plugging in the 2 at the very beginning, what we could have done is first just simply put the f of x function minus the g of x function. Okay? So we could have done this first, all right, which would give me 2x minus 4x, so that'd be a negative 2x, and then 3 minus negative 1, which would be a positive 4. Then you can just plug in 2, because that's what you're going to evaluate this guy at. So this right here, negative 2x plus 4, that is f of x minus g of x, okay? So now we can just simply put 2 in for x, so negative 2 times 2 plus 4, and that would give us 0 once again. So both ways gave us 0. It doesn't matter which path you want to go. I just want you to be aware of both, all right? And this same idea would work if the two functions were multiplying, if the two functions were adding, all right? You could either plug in the number into both functions and then solve, or you can put the two functions together and then evaluate. It's totally up to you. Both ways work, all right? All right, guys, this was a shorter video. I hope it helped. Let me know if you have any questions. Let me know if I made any errors. Let me know if I can be clearer on something. All right, have a great day.